If you learn 2 rules, you can figure out the polarity of every molecule in existence. The first condition is you need to have at least 1 polar bond in your molecule. And a polar bond is formed when you have an electronegativity difference greater than 0.4 between 2 of your atoms. This could include, for example, a carbon to oxygen, a hydrogen to nitrogen, fluorine to carbon. There's many different polar bonds, but if you don't understand what's going on here, watch our last video on polar bonds. The second condition is that a molecule also must be unsymmetrical and not in a one-way axis. It has to be rotationally unsymmetrical. As an example, water contains a polar bond, so it fulfills condition 1. But when you move its tetrahedral electron group geometry in all 4 possible combinations, they are not all the same. And that means water is rotationally unsymmetrical whilst having a polar bond. And this is a polar molecule. A great example of a non-polar molecule that does have polar bonds is carbon dioxide. Carbon dioxide is a linear shape, which means you only have 2 possible configurations where you have the carbons like this, or you have the carbons rotated around like this. In either rotational position, it's exactly the same, which means that this is symmetrical, and hence this is a non-polar molecule. So if a molecule has at least 1 polar bond and is rotationally unsymmetrical, the molecule is polar. Save this video for the next time you study chemistry, and follow us at Catalyst Chemistry for more HEC chemistry tips and tricks.